Alright, so I think I'm recording here. Let's take a look at these problems in our Skill 4 review packet. We have here polynomials, and they want us to rewrite it if necessary in standard form, then to find the degree and identify the leading coefficient. So here in number 7, if we rewrite f of x, um, we want the exponents to be in descending order. So our first term is negative 4/3 x to the third power. Then we have a second degree term plus 2/3 x squared. Then we have a linear term 6x. And we have a constant term minus 1. So the term of interest, this leading term, contains information that we want to know. The degree of this polynomial is that largest exponent, 3, and the leading coefficient is this negative 4/3. So when you're rewriting this in standard form, don't lose the negative signs that are with the coefficients. Problem number 8 is the same idea. We've got this negative sign, and I'm going to put negative 1 there, plus 12x. We don't have a constant term. Then it didn't ask. I'm surprised that we didn't identify the constant term. The leading term contains our information. The degree of this polynomial is 2, and the leading coefficient is a negative 1. Alright, so let's move on to the next ones. The directions are the same. Now, here we're going to have to multiply this out. If we distribute the 12x through, half of 12 is 6. So we have 3 terms. The term with the largest exponent is this negative 6x to the 6th. I do not have to fill in the zeros. If I were doing synthetic division, I would then write it 0x to the 5th and 0x to the 4th and so on. You know, any missing terms, I would use zeros as placeholders if I'm doing synthetic or long division. But here, and just writing it in standard form, you don't need to do that. So the information that we want is in this leading term. The degree is 6. The leading coefficient is negative 6. This problem is in factored form. If they did not ask me to write it in standard form, I could still find the degree. But here I don't look for the largest exponent. I look and see for each factor what does it contribute towards the degree. This first factor 1, this next factor 1, this next factor, even though this is a 1 here, 2 times 1 2, so this is going to have a degree of 4. And I can multiply I can rewrite this I can write this as negative x squared plus 6, and I can multiply the coefficients. 1 times 3 is 3, times a negative 1 is negative 3, and I know that that leading coefficient is going to be a negative 3. Now, if it wasn't necessary, if the directions didn't say write it out in standard form, I mean, that's normally when we're applying our leading coefficient test, or we're analyzing this, that's leading term. This is the information that we wanted from that leading term. So let's go ahead and multiply this out, though, because it is asking us to do that. We'll multiply this x term last. When we have the 3x and we distribute it through, we'll have 18x minus 3x cubed. If we distribute the negative 2 through, we'll have negative 12 plus 2x squared if I haven't made any silly errors. If I distribute the x through, I have 18x squared minus 3x to the fourth minus 12x plus 2x cubed let's write this in standard form in descending powers on our exponent. We have x to the fourth, x to the third, x squared, x. We do not have a constant term. So we were given a polynomial in factored form, or partially factored form, at least factored over the set of integers, and then we multiplied it out to write it in standard form. This leading term contains the information that we wanted with the degree and the leading coefficient, but we did not necessarily have to write this in standard form to identify that degree and that leading coefficient. We could have still identified it in factored form. Let's go ahead and do these. And again, if I rewrite this with the x term first, I can look at this and see that my degree, well, this is x to the first with the multiplicity here 1, so that factor is contributing 1 towards the degree. 1 times 1 here is 1, 1 times 1 here is 1, and 1 plus 1 plus 1 is 3. The leading coefficient is going to be negative 1 times positive 1 times positive 1, which is a negative 1. So, like I say, I can answer those questions without having it written in standard form. I can still identify that from factored form, but the directions asked for us to rewrite this in factored form. So I'm going to multiply the x plus 2 and x minus 2 first, and I'm going to put that negative sign. I'm going to factor out a negative 1 just because I like to have that leading coefficient be positive. I don't want to make a silly sign error. X plus 2 times x minus 2 is x squared minus 4. If I distribute the x through, I'll have x cubed minus 4x. If I distribute the 4 to both of those terms, I'll have 4x squared minus 16. If I distribute the negative sign through, if I rewrite this in descending powers, This time I do have a constant term. So that leading term here contained my information that I answered before. Degree is equal to 3 and the leading coefficient was -1. My exponents on my variable are in descending order, 3, 2, 1, and the constant term is written last. So that polynomial function is written in standard form. This next one is written term by term, so I don't have to multiply anything out. I just have to rearrange the terms in the correct order. So I see an x to the 5th term, and that looks to be the highest exponent. Do not lose the negative sign there with the 3/8. An x to the 4th term, here it is. I have a negative x to the 4th. Do I have an x cubed? Yeah, there it is. Do I have an x squared term? I do not. Do I have an x term? Yes. A linear term. 7/6 times x. And is there a constant? Yeah, this -5/3. So now this polynomial is written in standard form. Let's see, 1, 2, 3, 4. I had 5 terms. 1, 2, 3, 4, 5. I didn't lose any. As this number of terms becomes longer, I always count to make sure that I haven't lost a term. And then my exponents are in descending order: 5, 4, 3. There was no 2. 5, 4, 3, 1. And then my constant term. So I had 1, 2. I had 3 negative coefficients, and 1, 2, 3. I have, well, if you call that constant rather than calling it a coefficient, maybe I should call it a negative constant. But I haven't lost any sign. So things like that I have to do because I know I'm prone to accidentally, losing that negative sign that's a negative coefficient. So the information now that I want is in this leading term. The degree is 5. The leading coefficient is equal to -3/8. Alright, so I hope that helps, and I'll talk to you later.